So we are talking about factoring. Now, some of these things are like this one, for example, right here. This is a classic factoring problem where you take, it's called SOAP. There's a little acronym for it. So I'm going to write this in the upper right-hand corner so you can see what the formula is. If it was a cubed plus b cubed, that would factor into a plus b. So it's SOAP, same sign, opposite sign, and always positive sign. So the opposite sign of what's in there is a negative, and then it always ends in a positive with this particular type of factoring. So it's a plus b, and then it's a squared and b squared, and then it's ab in the middle.
Okay.
You remember this? And if it was a cubed minus b cubed, the way that would factor is a minus b, because the sign is the same as what it was, right? And then what would this first sign be?
A squared minus.
It wouldn't be minus.
Oh, plus. Oh yeah, plus. Maybe minus plus b.
And then plus, because it always is positive at the end. So the sign is the same sign as what is in the problem, the opposite sign of what was in the problem, and then always positive. That's why it's called SOAP. Okay. And so if you have a sum or a difference of perfect cubes, that's how those factor. So notice what we have here. We have that. You see how 27 is 3 cubed and x cubed is x cubed. So it's 3x cubed minus, what's 125?
5 cubed.
That's right. It's 5 cubed. Yeah. So what's my a?
3.
3x.
3x.
3 my a, and what's my b?
5 squared.
It's 5. Just 5.
Oh, 5.
And notice how it's a negative. So how does this factor? This factors into same sign, opposite sign, always positive. And what goes here in this first spot?
3x.
3x. And what goes here in the second spot?
5.
5. Good. And what goes here?
3 squared.
3x squared.
3x squared.
Which would be 9x squared. You don't write parentheses, right?
Okay.
What goes here?
15x.
Very good. 15x. And what goes at the end?
25.
25. Perfect. And that's how it factors. Now you have to check if it factors more, because sometimes you can factor this even more. This you don't have to worry about usually, although it could. Like these could have a common, there could be a LCD, but there isn't in this case. But sometimes this factors more. So you have to look at this as well. So could it maybe be 3 and 5, 3x and 5x? And it would not be, because that's way too big. 3, 5 is 15, but then there's 2 of those, so you'd have to have 30 in here, not just 15. So that doesn't factor, or that doesn't factor anymore. So this is just your answer. Okay, so that's called sum or difference of perfect cubes. That's one of those special, they call it a special factors or special product or special factoring rule that you see a lot, and it's just good to kind of have that memorized. Okay, so remember that one. Okay, these ones, well, look at number 4. What's that going to be?
Is that the same perfect cube?
Exactly, it's the same. So what's my case?
1.
1x. And what's my b?
125.
Well, that's b cubed. So what's b?
Oh, 5.
5
cubed.
So what would I have to write here? Tell me what to write.
X cubed plus
Do I write cubed?
Oh, no. Sorry. X plus 5
Mm-hmm.
and then x squared
Mm-hmm.
minus 5x
Mm-hmm.
plus 25.
Perfect. Now let's check it to make sure it works.
Mm-hmm.
Okay. The way we check it is we multiply it back out. So x times x squared is what?
X cubed.
Good. And x times negative 5x is?
Negative 5 squared.
X squared. Good. And x times 25 is?
25x.
Good. And 5 times x squared is?
5x squared.
Plus 5x squared. And 5 times negative 5x is?
Negative 25x.
Mm-hmm. And 5 times 25 is?
125.
Positive 125. Hey, look what happens. What happens to this one and this one?
Cancel.
They cancel because they're opposites of each other. And what happens to this one and this one?
They cancel.
You understand? And so your answer is just x cubed plus 120. Hey, that's exactly what I had. And that's what factoring is. Factoring is basically just writing an expression in a simpler way. It's writing it in a simpler, I know it looks more complicated, but it's a simplified version of it. Just like if I wanted to say, like, I don't know, 24, you can write 24 in a more simplified way as 6 and 4, or 8 and 3, right? Or 12 and 2. Or you can write 2 times 2 times 2 times 3. So these are all equivalent expressions to 24, but they're simplified or they're factored. They're written as a product of its factors, right? And there's a value to that. It's much easier to do certain things with, to solve problems or to find, asymptotes, or to find x-intercepts, or all these things that you've already done quite a bit. But factoring is important because in polynomials, it helps you break down polynomials into smaller pieces that you can work with more easily. Okay, so that's why we do that. All right, so this one up here, what would I take out first?
An x.
Good. And what would be left?
X to the 4th.
Minus
16x.
not 16x, because you took an x
Oh,
out.
just 16.
Good. Don't forget that. Now I'm going to write a formula up here. This one is a little bit more familiar for most people. A squared minus b squared. What does that factor into? Do you remember?
A plus b.
A plus b.
And a minus b.
Minus b. Yeah. That's a plus b and a minus b. Notice that there isn't a sum of perfect squares rule, because that doesn't factor. So in perfect cubes, it works for either a sum or a difference, adding or subtracting. But for perfect squares, it only works for subtracting. So there's only a rule for the difference of perfect squares, not for the sum of perfect squares. Okay. Now, do I have that right here?
Yeah.
I do. And what's being squared here? What's my a?
1 x or x?
No, what's being squared?
Oh.
Do you see how I really have x squared that's being squared?
Oh, yeah.
And what's being squared here?
4.
4 is being squared. So really what I get, what I have here would be, now don't forget the x that's sitting out front still, right? But what would my factoring be if I factor this out?
X squared plus 4 and x squared minus 4.
Perfect. Good job. Now, am I done?
No, you can factor it out.
Which one can I factor more?
The subtraction.
That's right. I can't factor this one anymore, like we just talked about, but I can factor this one. Now, how does that factor?
X plus 2 and x minus 2.
Good job. There you go. So that is your complete factorization of this expression. So now you might say, oh, but that doesn't look any simpler. But it is actually, it is simpler because it's broken this down and now I can see all the parts that make this up. And that's very useful when I want to find my zeros, or I want to find out where my, mostly zeros, but that's a very valuable thing. So this is kind of like doing this. Look at the bottom right. See how I said 24 can be broken down into its product of primes. If you keep factoring all of these, what would they all end up with? If you keep breaking them down more and more and more, what would all three of these end up with?
2.
2, 2, 2, and 3. Yeah, this is called the prime factorization. So this is like fully factored is what I would say. These are factors, but this is fully factoring, or this is the prime factorization. And that's what we did here. We just kept breaking it down until we couldn't break it down anymore. Okay. So if you only did this, your teacher would give you some credit, but you're not done. If you only did this, you get some more credit, but you're still not done because that could be factored more. That's your prime factorization. Okay. So I think you got this one now, don't you?
Yeah.
Let me see you try. Go ahead. Can you write on that? Do you have a smartboard or a iPad or no? Okay. You want to tell me what to write then.
Okay. So 2 parentheses 2x cubed minus 3 cubed.
2x cubed minus what?
3 cubed.
Perfect. Good. And what does that equal?
Equals to 2x minus 3, and in parentheses 4x squared plus 6x
Good.
plus 9
plus 9. Good. Good job. That makes sense now?
Yeah.
All right. How about this one? I'm on page 4. What do I do first?
You are going to take out an x.
Okay. So what would I have left?
You would have x to the cubes minus 8x squared plus 15.
You sure you did that right?
I don't think so.
Did you? No, how you can check is go ahead and try to plug it back in and see if it works. If I multiply this, or not plug it in, multiply it back out, am I going to get this back if I multiply this by this?
No.
No. What did you forget to do? Forgot to take one of the x's out of all of the terms.
Oh,
right?
yeah.
So it would be x squared, right?
X squared, yeah.
Minus 8x plus 15.
Wait, it would be x squared. It should take out an x from all 3.
See how, notice how in order to take that x out, it has to be in all of them. But if you took one of the x's out of this, how many would you have left?
2.
Good. So that's why that's a 2. And if you took an x out of this term, if you factored it out.
1. Oh, okay. Okay, that makes sense. Yeah.
Okay. So am I done, or can you factor it more?
I don't think you can factor it.
You don't think you can do it anymore?
No. Well,
what might you be able to do with this one?
can you factor out the x squared? Or
tell me what you can do with that right there. Do you remember how you can turn this trinomial into two binomials by unfoiling it?
I don't think I ever learned how to do that.
Okay, you did learn it, but you maybe just don't remember it. So here's how you do it. You take this one right here.
Mm.
A lot of teachers teach a different way, so I'm going to teach it like this. This is your first, which is going to be here and here.
Okay.
So how can you break up x squared?
X and
X and what? Yeah, x and x. Good. And then this one over here is your last.
Mm.
And so it has to go here and here. It's got to multiply to that and that.
3 and 5.
Okay, let's try 3 and 5. Do you want them to be positive or negative? Because they can both be positive or they can both be negative.
I think one positive 3 and a negative 5.
Well, they
Or
can't
can
both.
you do? Well, you can't be. Oh, they can be different.
Yeah, in this case, they have to be the same because remember, it has to be a positive 15.
Yeah.
How can I make a
So
positive? I can go
neg-
5 and 3, or I can go -5 and -3.
negative 5 and negative 3.
Yeah, let's try that. And now this one right here is your O plus your I.
Mm-hmm.
So let's check it now. When I multiply my outside and my inside, what do I get?
Negative 5x and negative 3x.
Yeah, and what do those add up to?
Negative 8x.
And that's what I needed.
Mm.
So that's correct.
Okay.
That's how you factor trinomials into two binomials.
Okay.
So what you're doing is you're unfoiling it.
Mhm.
And there's a little riddle you can use. When there's a 1 right here,
Mhm.
when there's a 1 in front here, the riddle that I say is what multiplies to 15 and adds to -8.
Okay.
What multiplies to 15 and adds to -8.
Mhm.
So the answer is -5 and -3. And so that's your answer.
Mm.
Okay.
Yep.
That makes sense how we did that?
Yeah. Yeah.
Okay. So now this one's different because there's not a 1 here, or there's not a 1 in front.
Mhm.
Now there's different ways teachers teach this. Has your teacher taught you something? A way to do this?
Probably. I was sick the day we did this, so.
Okay. So I'm a little hesitant to teach you a specific method because it can be very confusing. There's several methods that teachers employ to do this. So I'm going to just teach you the same way I just taught you. I'm going to teach you what's called guess and check or reverse foiling.
Oh, I do remember her talking about this. Yeah.
So I like to call it reverse foil or guess and check. So what we're going to do is we're going to write this out. And we know if this factors, see how there's no GCF, there's no greatest common factor in all these 2 and 13 and 11, they don't have anything and they don't all have an X. So if it factors, it's going to be like this, where you've got a binomial and a binomial. Do you understand?
Yeah.
Okay. And this is your first. So that has to go here and here. So what multiplies to 2x squared? There's really only one option.
1 and 2.
Yeah, 1x and 2x.
1x. Yeah.
1x and 2x. Okay. And then this is your last over here. What color did I use for this? I don't remember. Yellow. Okay. I want to be consistent. This is your last over here.
Mm-hmm.
So what multiplies to 11? How many times?
11.
Either 1 and 11 or -1 and -11, right?
Yeah.
You can also mix them up, can't you? You can put them in different orders, right? 11 and 1 or -11 and 1. Okay, so we're going to write that in here. We're going to just guess. We're going to guess something. What do you want to guess?
-11 and 1.
Okay, so -11 and -1.
-1.
Okay, and now let's check it. and I check it in red, I believe. Nope, in green. I'm checking it in green. So what's my outside plus my inside?
And then the outside is negative 2x, and the inside is negative 11x.
Good. And does that add up to positive 13x? Is negative 11x plus negative 2x or minus 2x, does that equal positive 13x?
No, it equals negative.
It equals negative 13x. Oh, that's so close. So what can we do to make it work?
Make both them positive,
Perfect.
like the negative 11.
Yep. And now does it work?
Yeah.
There you go. So that's how it factors.
Okay.
That makes sense?
Yeah, that makes a lot more sense.
All right. So go look at your homework. We got about 8 more minutes. Let's try to find some more problems, and then you can practice them, and then I'll do them, and we'll just roll through it, because the best thing for you to do to get this is to practice. So this factors 2x plus 11 times x plus 1. So you can just tell me what, you don't have to put it on there. You can just tell it to me and I'll write it down. So look at homework or look for more problems.
Okay, let me run upstairs real quick. Actually, no, I have them. I was just in the car. We were coming back from like a dinner. I have one. This one is actually, wait, no, I'm gonna run upstairs real quick so I can grab my paper.
Okay, go for it.
I can get I can do the 4 ones with the grouping, because I don't really understand how to do grouping.
Oh, grouping. Yeah, that's another. Oh.
Okay, I will be right back in here.
Okay.
Okay. Another one is x cubed plus 2x squared minus 4x minus 8.
Okay, so this is what's called grouping. This is one that's called grouping. So you notice that there's no GCF, right? You can't take the same thing out of every term, right?
Yeah.
But if you look carefully at it, you'll notice that if you group these two and these two, then you can factor the entire thing differently. So I'm going to group these two and take, what do these two have in common?
An x.
An x squared.
X squared.
And what would be left if you take an x squared out of those?
X plus 2.
Mm-hmm. And what do these two have in common?
A 4. Negative 4.
A negative 4. Good. A negative 4. And if I take a negative 4 out, what would be left?
X minus 2. X plus 2.
Right. And now what do these two things have in common now? What factor do they have in common? Remember, the factors of this are x and x, and then and x plus 2, right? And the factors of this are 4, or 2 and 2, and x plus 2. So what do these two have in common?
An x plus 2.
They both have an x plus 2. So if I factor that out, kind of like, imagine if I had like x squared times a minus 4 times a, what could I factor out of there?
Could factor out.
What do those have in common? What do these two terms have in common?
An a.
So if I took an a out, what would be left?
X squared minus 4.
You got it. right? And then you can do more to this, right? Because what's x squared minus 4?
X minus 2x plus 2.
Perfect. Good job. So that's exactly what we're going to do right here. You see how they both have this factor? That's my A. You see how that's the same problem? So I'm going to take that out in front. I'm going to pull that out. And what's left behind is going to be an x squared and a negative 4. And then this factors more into x plus 2 and x minus 2. And of course, don't forget about your x plus 2 to start. And so there's your answer right there. Now you can write this in a simpler way, because how can I write this times itself? What does that mean?
X squared.
X plus 2 quantity squared.
Yeah.
So that's how your teacher might have it in the answer key, or that's how your teacher might want you to have it. But that's it.
Okay.
Okay, does that make sense?
Yep.
All right, got time for a couple more if I do them quick. So you want to tell me one?
Okay. X. Actually, wait. Hold on. That one is a graphing calculator.
I have a graphing calculator. It's fine.
Okay. Well, no, because I know how to do those. Like when we do them on the calculator, it's just like doing them. Oh, here you go. 4x squared minus 16x plus 15.
Okay, so notice there's no GCF, right? So I can't take those out. So this is going to have to be if it factors, which by the way, it doesn't have to factor. But if it factors, it's going to have to be like this. And so this is going to be my classic. This is my first here and here. So let's just try 2x and 2x. It could be 4x and 1x though, right? But let's start by guessing 2x and 1x. I'm sorry, 2x and 2x. Got it?
Yep.
And then my last, what are we going to guess for that?
Negative.
Let's just
5
guess negative 3 and negative 5, right? Good. Negative 3 and negative 5, right? And now let's check. Let's check if that worked. 2x times negative 5x is negative 10x. Negative 3x times 2x is negative 6x. Look at that. We got lucky on our first try. Because those add up. So that's how it works. But guess if that didn't work, what would we do?
See, like make them positive.
Yeah, try something else. Making them positive wouldn't work. You could probably see that wouldn't work. But maybe switching them, or maybe making this a 4 and that a 1, right?
Yeah.
1x, or guess and check. Okay, makes sense?
Okay. Yep.
All right, hopefully that made sense. If you go to my website, 204tutor.com, or to my YouTube channel, actually, you can see, no, actually it's on my website. You can see there's a whole playlist for factoring if you want to go check that out. And that's a major thing that kids ask all the time. And so not going away. So keep practicing.
All right, thank you.
All right, bye-bye.
Bye, see you.